we've currently been looking at functions with notation of f of x, but we're going to look today at inverses, which has a notation of f negative 1 of x. So any inverse that we're looking at has a notation of f negative 1 of x, where the negative 1 is referring to an inverse. This inverse function is found by reflecting the one-to-one relationship against the line y equals x. So prior to this, we've been reflecting along the x-axis or the y-axis, but we're now actually looking at the line y equals x, which is a horizontal line in the positive direction, and we're reflecting along that line. To find the inverse of a function, you need to switch the places of the x and y, and then rearrange to make y the subject. For this inverse to exist, the relationship needs to be one-to-one, i.e. it has to pass the horizontal line test. So for example, if we have a Cartesian plane, I'm going to dot in my y equals x line, always put in your y equals x line, and a function of y1. So I put in my original function, or f of x, y1, and I'm now about to find the inverse of this. Now, key points to find: if it hits the y equals x line, our reflection line, then your inverse will also hit there as well. So this pink dot refers to where my new graph will go. If my y-axis has an intercept, then that becomes an x-axis intercept. And if my x-axis has an intercept, i.e. here, that's now a y-axis intercept. So there's a direct relationship between your x-axis and y-axis intercepts, in that you will switch your x's and y's, which makes sense as a inverse is the switching of x and y. So when we do this, we can graph a new line, and this becomes our inverse line, so our negative 1 line.